back. In this video, we're going to use the definition of odd function to prove that a specific function is odd. So I just want to remind you of the definitions. A function f is called even if f of negative x is the same as f of positive x for all x in the domain of the function f. And the function f is called odd if f of negative x is the opposite of f of positive x. So that means the y value or the output of the function has the opposite sign for all x in the domain of f. All right, so let's look at a specific example. So in this example, we're going to prove that the function g of x equals negative x to the fifth plus x to the third minus x is an odd function. So just like when we proved that something was even, what we have to do is plug in the variable negative x. So g of negative x, now using that polynomial, I'm going to write it's equal to negative x to the fifth. Now notice I have negative x in parentheses. That's really important. In the original polynomial, g of x, we're taking x and raising it to the fifth. And then we're putting a minus sign in front of that. Remember, order of operations, exponents come first. But when we plug in negative x, so we're replacing x with a negative x. So we have to take negative x, raise that to the power 5, and then put a minus sign in front of that. And then the same thing with x to the third. We're replacing the x with a negative x, and then taking that to the third power. And then the same with x. So we're subtracting x. So when we subtract negative x, we're doing that. Okay. So now let's simplify this a little bit. So note that the first term is negative and then negative x raised to the fifth. Remember that when you take a negative number and raise it to an odd power, what that does is you're taking negative x times negative x times negative x times negative x times negative x. There's 5 of them. And when you multiply a negative number times itself an odd number of times, you end up with a negative number, not a positive number. So negative x raised to the fifth is the same as negative x to the fifth. So note on the left side there are parentheses. On the right side, no parentheses. On the right side, what we're doing is we're taking x, raising it to the fifth, and just throwing a single minus sign in front of that. But on the left side, what you're doing is multiplying together 5 negative x's. But the two answers are the same. So let's keep simplifying g of negative x. So the first term is negative x raised to the fifth. So we're going to change that to negative x to the fifth. All right, it's very subtle. And then the next term is the same thing. We're going to change negative x raised to the third change it to negative positive x raised to the third. And then the last minus negative x, that's just plus x. So this is just some algebra, but you have to remember all the rules, the orders of operations. Exponents always come before multiplication. All right, so now we can keep simplifying. So the first term is just positive x to the fifth. The second term is negative x to the third, and then the last term is just x. So now we look at what our answer is, and we go back up to what the original function was, g of x. Well, g of x was negative x to the fifth plus x to the third minus x. And that looks pretty similar, but it's not the same. But notice with my answer, x to the fifth minus x to the third plus x, I can pull a minus sign out of each term, or I can multiply each term by a negative 1, and I get this polynomial. I get negative, and then parentheses, negative x to the fifth plus x to the third minus x. take a look at that. Now, if you distribute that minus sign, you will get the polynomial right above that line. So the last line, all it is the previous line with the minus sign factored out, or the -1 factored out. All right, so now what do I have inside the parentheses? Well, I have g of x. So what I've got here is the opposite of g of x. I've got negative g of x. And so according to our definition of odd function, g is odd if g of negative x is always equal to negative g of positive x. And that's what this function does. So we know this function is odd. We've just proven it's odd. All right, let's do another quick example. So in this example, the question is g of x equal to -3x to the third minus 5x plus 1, is that function even, odd, or neither? So it's possible that a function could be neither even nor odd. So let's check it out. So I'm plugging in negative x, so g of negative x has to be -3 times negative x cubed minus 5 times negative x plus 1. Now let's simplify. So -3 times negative x cubed is the same as -3 times negative x cubed. And then -5 times negative x is plus 5x. And then I have a plus 1. So now in that first term, I have a negative times a negative, so that's a positive. So I've got 3 times x to the third plus 5x plus 1. And now I compare it to my original polynomial, g of x. Is g of negative x equal to g of x? No, it's not, because g of x has a negative first and second term, but the third term is positive. So they're not equal. And so it is not even. And g of negative x is also not the same as the opposite of g of x, because the opposite of g of x is negative g of x, where we would just change each sign. We would get a positive 3x squared, a positive 5x, and a negative 1. And that's not what we have here. So this is also not odd. So that means our function g of x is neither even nor odd. All right. So when you're asked to prove or asked whether some function is even or odd, you need to use the definitions. And you might have a good intuition about it because you're familiar with polynomials or trigonometric functions, and you might have a good gut feeling that it's going to be an odd function or even function or neither. But you really do have to plug in negative x, because according to the definitions, it has to be true for every x in the domain. And the domain is always infinite. There's no way you can test an infinite number of real numbers. All right. In the next video, we're going to look at the graphs of even and odd functions and see why we call this symmetry. And I'll see you there.